My guest today is Sergey Gorbanov. He's the CEO of Axelar, and we're here at Interop Summit in Denver. Axelar announced Axelar VM here at the event this week, and so we're going to learn more about that, understanding what it is and how it can help developers build better cross-chain applications. Before we get started, make sure to hit the like button, hit the notification bell, and subscribe to get notified when I go live every week. And remember that none of what we discuss here on the Interop is investment advice. My guest, Sergey, is coming up next, right here on the Hello, how you doing?
Hey, good. How are you?
Yeah, thanks for doing this.
Yeah,
in this very special kind of live setup.
Yeah.
Yeah, it's always weird to be away from my home studio, so I hope this works. And it looks like we already have people in the live stream. So congratulations on this event.
Awesome. Yeah, thank you.
It's really impressive. A lot of people have been asking though if we've been organizing the event. So so it's yeah, the naming collision is kind of funny. But yeah, I really enjoyed it. I thought there was like good quality people here. And what was really interesting is that like it really feels like being here. Everything that I believe is as far as like the multi-chain future and the interchain is really sort of coming together at this event, and the narrative that the event is really pushing forward. It sort of aligns with that. What were some of the big highlights for you?
Yeah, so I think for me, it's been actually really surprising to see all the different ecosystems come together and talk about interoperable future, right? So I think over the last few years, over the last bull cycles, we always see a lot of talks from different layer ones, different software stacks, like this stack is best, this stack is best, and so on and so forth. And we should continue innovating on those things. There's still a lot of work to be discovered. But I think understanding the problems that the developers in the industry has towards right now that everything is super fragmented, that actually creates a lot of friction for the developers. It creates a lot of friction for the users. And we as an ecosystem, if we want to scale, like that has to be solved, right?
Yeah.
And that was really like the core objective of this conference, is to get everybody together and say, look, like, we can talk about the same 1,000 developers being shuffled from one ecosystem to the other, but at the end of the day, our job is to grow, right? And show to the people the power of the technology behind blockchains, and that means actually working together on some common problems.
What were some of the big trends that were discussed here at the event?
Yeah, so a lot of the talks have been around basically how do users interact with different blockchains, right?
Yeah.
So just now we had a panel across different layer 2s, right? And even there, the question is, well, you have ETH you use as a token across all of these different layer 2s to power gas, but what does it mean for the user? You just still have to like bridge that ETH from the main chain to like your layer 2, right? Flip the wallet switches and things like that. So I think a lot of the talks about how do we abstract away the user complexity. So there are things like account abstractions that a lot of developers are talking about. Build better applications using those primitives.
Yeah, I think account abstraction is a really interesting primitive that is really needed. And there's been some amount of account abstraction through wallets like Argent, in the last couple of years. But I mean, these were just really the beginnings, I think, of what account abstraction can be.
Right.
I feel like with account abstraction, the idea is the outcome is really interesting, where you essentially you can tokenize an account, right? You can turn an account into sort of a non-fungible asset that can be transferred. It can be it could be sold, right? Like you could have a company that holds assets, and that those accounts would hold several assets, and they would be sold to someone else. Like, how do you see account abstraction really sort of turning on its head the idea of the wallet and like this thing where you have a private key, you secure that private key, and then
yeah. I mean, you're probably still gonna have some notion of a private key somewhere, right? Because that's what gives you the ownership, right? Of any type of identity that you have in a blockchain. But I think the point is that how do you go back and interact across all of these different chains, right? Like, do you pay gas in multiple currencies, right? How do you interact with one ecosystem versus the other? And so I view account abstraction as a sort of a step forward for the users at the end of the day, right?
Do you think that in the end, doesn't it also diminish the importance or some of the security assumptions. We have our own keys, because with account abstraction, you could essentially have like as a user, just as basically as an individual, right? You have an account. You could have several keys, sort of in a sort of personal multi-sig managing this account, and so therefore the individual security of any one of those keys and like storing the seed phrase, and like it sort of diminishes the importance of key security. Not that key security is not important, but like you can sort of spread that risk across different keys in a way that's not necessarily possible now.
Yeah, so no, for sure, right? Like I actually view that the kind of security policy around accounts is something we still have to innovate around a lot, right? So for instance, you go to your bank account, okay, maybe you set it up. There's all kinds of security policies that authorize a certain number of transactions that you do, right? Certain volume of transactions that you do per day or per week, right? If your account gets compromised, there are various ways to recover it, right? So we don't have any of that in the blockchain. There's one wallet, you lost it, you're kind of done, right? And so by effectively programming a lot of security and access control policies in those accounts, we can create something that's uniformly used by the user across all the different ecosystems, gives them better security, but also gives them recovery if things go wrong, right? And that recovery could be because you set up your own, like, multi-sig or kind of key splitting. It could be because you collaborate with some entity that maybe is providing like a, backup recovery if you don't touch your wallet for like a month, right? In an emergency situation.
Yeah.
So you can actually code very interesting like policies around those things now.
Yeah, no, I think it's. I think that in the next cycle, the next 3 or 4 years, like account abstractions is going to. I mean, for one, I think it makes asset custody just so much easier for users, right? I mean, the opportunity to build really interesting sort of things like this, right, where you actually abstract the account away from recovery and ownership, and like these sorts of models will just create really unique and interesting products for users, for companies, for like any type of person or a company that wants to interact with crypto. They're going to have products that are going to enable them to do that, depending on the use case, the amount of assets, the value of those assets, etc., and adjusting for risk. So yeah, I'm pretty bullish on that.
Sure.
On that whole front. So we last spoke in September. Lots has happened since then. So maybe just giving a brief update on like where Axelar is at today, and obviously, like you've announced the VM here this week, but since September.
Yeah, I mean, high level, the last year the network has gone live with connections with all kinds of different chains, right? So we're connected over 32 networks throughout the stack, everything from a lot of EVM chains, a lot of Cosmos chains. They're all interoperable. You can send messages back and forth. You can send assets back and forth. We processed, over 1.8 billion in kind of cross-chain volume, like hundreds of thousands of requests have been served. And we are working with a lot of developers to think about how to build Interchain native applications, right? So leveraging things like account abstraction, leveraging things like you can pay, on one chain or submit a transaction on one chain, still execute it across multiple different systems. So I think as we've been building, I think we're discovering that there's a lot of infrastructure pieces that are missing, right? It's not just about, interoperability protocol that you use underneath it, but it's actually the whole interoperability stack that needs to be built, right?
Yeah.
And so the last 6 months in particular, we spent time both thinking at the network layer what has to happen, but also what are different services around the network that need to be instantiated to enable experiences like we talk about here, and simplify the developer build-outs across multiple ecosystems. This is something where we've seen a lot of problems where, as a developer, first you got to pick chains, right? This is just like a hard problem on its own.
Yeah.
And then you think about how do you actually build on all of those chains? How do you deploy your contracts? How do you manage them across all of those environments? So still a lot of fragmentation, still a lot of kind of complexity that has to be abstracted.
Like what is the most important thing that needs to be abstracted if it's not account abstraction, and what are some of the pieces of the puzzle that still have to get built in order for the developer experience to get better? And
yeah, I mean the first one, which is pretty elementary and it's getting solved right now, but the notion of having like Interchain native tokens, right? So right now, a lot of the tokens, you're issuing on one chain, then you pass it through one bridge, maybe another bridge, you get like wrapped versions of different chains. Users are just completely, fed up with all that experiences, right? So, through the Axelar stack, we build things like Interchain tokens where you can just go and deploy a token. It's available across multiple chains right away. It has, mint and burn functions, which are kind of pretty secure. You can have all kinds of additional security checks on top of it, and really have like a uniform token that has one representation. You don't need to wrap it into any other formats. It can be displayed very easily in the wallet, and then you can like sum up the balances, right, of all the different chains that the user has this token on, and just display like one number.
Yeah.
So I think that's like as a building block something we've seen kind of a lot of demand for, and we try to automate a lot of it.
Is the idea here, because we talked about this last time, we talked about the fungibility
right.
Problem with bridging. Is the idea here that tokens would be instantiated, or like they would be deployed on Axelar, and then Axelar offers the security guarantees to then deploy them on other chains? Like it sort of initiates on Axelar?
Yeah, so the token is not actually deployed on Axelar. We think of Axelar as kind of connectivity tissue, but Axelar will allow you to instantiate and deploy that token across any other chain that you want. And Axelar will connect them all together. So they function as one. So you can think of it as like, like ERC20 format, right? It's pretty simple. There's like a transfer function and a couple others. And we extended with a couple more functions that allow that token to be chain agnostic, right? So you can send it around.
So practically speaking, let's say I'm launching an application. I have, I want to have my token on Ethereum and in the IBC ecosystem, and maybe on Solana.
Right.
I deploy. I mean, like, there's an instantiation event that happens on Axelar. Those tokens would be native tokens on each of those chains.
That's right.
And then Axelar acts as they sort of ensure fungibility between them, such that you don't need to have a wrapped token.
Exactly.
Okay, that's really interesting.
And you can extend that, right? Like, so today you deployed it on 5 chains, and tomorrow you want to have access to 5 other chains. You can extend that without, again, creating this additional fragmentation, right? So they will still function as one, so you can expand and shrink them as you want.
Okay. And so as you're moving tokens between, say, chain A to chain B, Axelar is acting there as essentially sort of burning that token on the Axelar layer and ensuring that over on chain B it gets minted in the same way that, say, like IBC works or something like that.
Yeah, so the token still kind of gets burned and minted on the edges, right, on the chains that will connect, but the Axelar uses the attestation layer, right, or verification. So, you send your token on what we call as like a gateway, right, on the source chain, and Axelar will verify that it's been correctly burned, and then authorize the corresponding action on the destination chain.
So it's all just message passing.
It's all just message passing.
Okay,
exactly.
That makes sense.
Yeah.
All right, that's really cool. And then, so how do you think about stuff like, because obviously where this starts becoming complex is when you have multiple standards. So in Cosmos and Ethereum, for instance, and these 2 ecosystems that I'm pretty plugged into, they've mirrored each other's ERC20 to ICS20 and the 721, and over on both chains. Other chains are going to have, I'm not like super plugged into Solana, but I imagine that token standard is totally different, and so for NFTs as well. Do you guys do like standard compatibility between those chains so that the messages actually do get routed? And
yeah, that's a great question. That's actually one of the core services that the Axelar network provides. It's what we call as message translation, right? So if you send a message from an IBC or Cosmos chain that has its own kind of a packet format, how do you then translate it in a packet that can be executed on EVM chain, right, or a move chain or something else? And so the network itself has all these translation properties at the core, so it does them like efficiently in a secure way. And from a developer's perspective, then you don't have to think about those things, right? So you build, in Solidity, like using whatever ERC20 standard you like. If your token needs to transfer or needs to go to a Cosmos chain, the Axelar network will take care of it, right? So you don't have to think about it. And then on Cosmos side, you receive it or some other user receives it. They interact with the way they like, right? Because it's encoded in the format that's accessible to that ecosystem.
I mean, that's a lot. I mean, that implies a lot of integrations, and also, there may be token formats that, I mean, like NFTs and sort of regular tokens are pretty standard, but like some chain might think about Regen, for example. Like Regen has a token standard that they issue their carbon credits with. I think probably there's something equivalent on Ethereum. Maybe Solana doesn't have that sort of thing, right? Like, so how does that? So then when you're deploying, say you allow that deployment, as a developer, I just wouldn't be able to deploy it on Solana, or would you also encourage sort of building those token standards in other ecosystems so that we have better standardization?
Yeah, no, great question. I mean, that's exactly, kind of back to the point why we announced kind of the launch of the Axelar virtual machine, right? Is to enable developers to kind of customize and extend, things we can do or other teams can do around the Axelar stack, right? So if there's a certain chain that has a different format, all you need to do is kind of write certain translators to that chain, and then automatically they will be able to kind of speak with a language that's familiar to all the other chains.
Okay.
Right. So Axelar can use as a uniform kind of translator language, almost like a Google Translate, right? Like you put one language on one side, you can translate it to the other language that needs to be sent to the other chain. So we'll do some work, of course, around standardization, right, and helping the standards spread. But with the Axelar virtual machine going forward, developers will be able to do that themselves.
Okay, well let's talk about it. Let's get into this Axelar VM. So there's two parts to it. There's the amplifier and the Maestro. So
yeah,
let's break that down.
Yeah, so those are what we call as like services that we want to launch with, as the VM goes live. And the basic problems that we're trying to solve with it, kind of the need for connectivity across different stacks, right? So right now a lot of connections are done at the network layer. So there's validators kind of register to vote on events from certain chains. Then certain routing packets are being enabled, and then you can send packets back and forth across them. How do you extend that to support more and more ecosystems? And previously you would have to write like a module on the network layer, upgrade every validator. It's a pretty delicate process, right? Yeah. And so with the Axelar virtual machine, effectively you'll be able to code those connections yourself and make them still interoperable with with the rest of the Axelar stack, right? So suppose there's a connection to like a Solana that you want to build, and maybe that connection actually leverages different technologies like zero-knowledge proofs or light clients. You can plug them in, right? But sort of at the cost of making one connection to the Axelar network, you get to route your packets to all the other ecosystems that have been interconnected through the stack.
Okay.
Right? So that's what the job of an amplifier is, effectively, help you amplify the work that you could do as a developer to build a connection to make sure it's not a one-off connection between A and B, but it's really one-to-N connection, where one connection can access n different ecosystems.
Okay. Can you give me like a practical example of how like an application would use this? Because it's not fully, I don't have the full mental model.
Yeah. So this is not for applications, but this is more for like core protocol developers that are building layer ones or layer twos.
Okay.
Right. So as an example, you build in your own chain.
Yeah.
Okay. Based on whatever Rust language and some fancy consensus optimization logic.
Yeah.
You want, as you go to market, you want to have connectivity with other ecosystems. You want to make sure that developers and users can bring liquidity over, bring stable coins and things like that, right? So, how would you do that? You effectively want to build a connection. And so you can go and then instantiate this connection with the Axelar network to make sure that as you go to market, right, as you keep on building your stack, information in and out of your network can continue propagating, right? So this is a kind of a service that not something like a dApp developer would use, but kind of consensus or protocol developer,
like a layer one, like an app chain or a roll up.
Exactly.
Okay.
Yeah.
Interesting. Just realized we're on the wrong mic setting, but that should be fine. Sorry. Put it back on normal. There. All right. Okay. So as an application developer, as an app chain developer, or roll up. This is where it gets complicated because an application is, a settlement layer and potentially all the way down to consensus, right? So
sure.
You're what you're saying is this is not for smart contract developers, but applications that are building as a sovereign execution environment or settlement layer.
Yeah, or if you just build in, your own layer one or layer two, right, or a roll-up layer. Like a lot of them are actually, some of them are application specific, but some of them are general purpose, right?
Yeah.
So we have, ZK Syncs, we have Optimism, we have, Arbitrum. All of those are, layer twos that are general purpose and they still want to have connectivity, right? And so how do we allow them to do that in an easy and efficient way? And so that's what the job of an amplifier is on the network, effectively.
Okay. And so then, effectively, I'm building my layer one. I don't know, it's like some DeFi layer one, right? Yeah. Like as a Cosmos app chain, I want to be able to leverage liquidity from other ecosystems.
Right.
I would use the amplifier to deploy my a contract that would allow other chains to interact with my application.
Exactly.
Okay.
Yeah, with all of your applications, right? So kind of right now, the way the connections are established across different chains is we deploy this notion what we call as a gateway, right? Gateway is a smart contract. You can think of it as a router. And so information, as it goes to one chain, it goes through this router, right? Yeah. And so in the same way, you build in a new layer one, you can deploy one of these gateways on it. You can deploy, corresponding gateway on the Axelar network. that establishes a connection between your chain and Axelar network. But because Axelar is sort of a hub, it has many other connections. Once you go through some governance process, then your packets can be routed to any of those chains.
Okay, and like, does this is this similar to this notion of outposts that a lot of chains in the Cosmos ecosystem have been talking about? I mean, essentially, it's sort of building outposts on other chains, right? Like,
I guess I'm not quite sure. What is an outpost?
Well, an outpost is like so Mars, for example,
Yeah.
they have this notion of outposts where like Mars orchestrates message passing between. I think they do. I mean, between contracts that are deployed on different Cosmos chains, and they offer. I think they also have like a liquidity backstop, so that all of those different sort of liquidity positions on other chains can leverage in case there's like an issue or something like that. Is that the vision here, or is it more than that?
I mean, for the amplifier itself, kind of its core job is to make connections, right, and make sure those connections are as secure as possible. So at least what you described, I think it's sort of an application leveraging those connections, right? So like Mars is probably like relying on IBC or some other
they rely on
protocols. And so the question is, when you don't have IBC available, right, or other protocols, how do you instantiate the connection to begin with? So I would say it's kind of a lower layer primitive at the networking layer, at least the sort of the amplifier, and that Maestro is slightly different.
So there's a question I wanted to ask later, but I'm going to ask it now, which is, well, I mean, IBC is becoming more standard outside of the quote unquote Cosmos ecosystem, right? So there are implementations of IBC that are at least being built or maybe even deployed on Near and Solana and like Avalanche.
Yeah.
And then it's possible also with one slot finality to do, or at least in theory, I've been told it's possible to do IBC on Ethereum. What kind of role how does Axelar's role evolve when there's essentially pretty widespread adoption of IBC, or it could even be that like the entire EVM space has its own interoperability protocol. Cosmos has IBC, and you don't necessarily need to deploy on every Ethereum roll up, because you can just do one, and then your tokens will be able to move, and your messages will be able to pass without deploying on every single chain.
Yeah, so I think there's a big difference between a pairwise protocol that connects A and B and utility of interoperability in the space, right?
Okay.
So kind of the way we view Axelar is it's a service network, right? It provides various services. One of them is connectivity. We can talk about like Amplifier, which is like helps you with interchain orchestration and management services like that. And there are various services that need to be instantiated across the stack to make sure the applications can actually talk to one another, to make sure tokens can be deployed across different environments, and so on and so forth. So we think of Axelar and like the network around it is really a full stack. Right? There's a network component to it. You can instantiate connections to the Axelar network any way you want. There's IBC, you can plug in IBC, right? If you don't have IBC, you can instantiate external validation. If you have zero knowledge proof, you can instantiate that, right? So we are kind of a protocol agnostic for pairwise A to B, and we're trying to think about what are the network services or services on top of the network that have to be built to actually then enable developers to interact across all of these different ecosystems, right? So, one example, across EVM chains, we talk about account abstraction. But today, if you're using like any of the bridges, anything else, you have to have tokens on all the chains. You have to flip your wallet back and forth.
The fungibility problem is not solved yet.
It's not just fungibility, but also like the wallet experiences. And the developers don't know how to build those types of wallets or account abstraction primitives. So how do you allow developers to submit transaction one chain that gets executed across 5 different EVM stacks today? Right? You can't do that, right? And so there's like a service on top of the network, like a gas service that we deploy, that you can pay, in the token on one chain, and then your transaction will get executed across multiple different stacks, multiple different chains. So it's over a step forward towards the account abstraction across all these different stacks. And so that's how we always think about how would developers interact with these things. Developers not going to interact with the IBC. I can tell you that.
Yeah.
It's a low-level protocol.
Yeah.
The developers not going to interact with CGP, which is the kind of protocol that we built to interact with across different chains. Developers want much simpler APIs. They want much simpler experiences, right? And that's what we're building effectively through the stack.
Where's the wallet sit in all this? Because I usually mentioned the issue. One of the biggest issues in crypto is wallet fragmentation, asset fragmentation across different wallets. Like I've got like 6 different wallets.
Yeah.
And then on top of that, maybe like one on my phone that's not the same seed as the one on my computer. Like, I mean, where in this, interchain future where Axelar plays a significant role in allowing interoperability between different state machines. Where does the wallet sit? Does it sit on Axelar? I mean, like, do the tokens sit there, or do they? Yeah, it's unclear to me there.
Yeah, so I think to me, like the reason the wallets are very fragmented is because you did not have interoperability infrastructure to make a chain agnostic wallet, right?
Yeah.
So I think now with sort of Axelar and a lot of the other interoperability stacks that have been built, you can actually build a wallet that sits. You can define chain that you want to sit it on, right? Like
Yeah.
you want to sit it on Ethereum, great. You have a main maybe account on Ethereum, but that wallet can interact with its, kind of a versions on other chains, right? So you can have smart contracts that are still representing your account, right, through account abstraction paradigms. They can all talk to one another, and from a front end perspective, be displayed as one unified account for the user, right?
Yeah.
So I think for me to instantiate these wallets, it will effectively have to come down to two sort of, again, layers that have to be built. One is this layer of kind of account or cross-chain contracts that represent your account across different ecosystems, and then wallet sort of that aggregates all of that in one way or another and just displays it in a uniform way for the user, and the user can submit transaction from any of these accounts, and they actually function as one, right? So I think a lot of the wallet architecture is going to be rebuilt over the next few years, right? Leveraging these paradigms.
Yeah. What role do you think things like MPC, will be? How will MPC be integrated in this paradigm?
Yeah. So I mean, MPC, I guess, for those that don't know, it's like multi-party computation protocols, right? Basically you can think of it as a kind of either a multi-sig, right, or other types of threshold
at the encryption layer.
Yeah. And so the question is, how do you manage all these different accounts? I think back to the account abstraction question. And the way to manage it is by setting up multiple keys that could have different policies associated with them to execute these actions, right? So, if you want authorize your transaction from multiple devices, then certain MPC or technology could come in to help you co-sign transaction across your phone, maybe your desktop, maybe like a ledger device. It's submitted as one transaction on chain, and then it gets propagated. You could have a secondary policy on that account through the MPC that deals with recovery, right? So if you lost your cell phone, but you have two other devices, you want to be able to instantiate a new phone, so you can run through like MPC protocols to create another key. Or if you lost two of your devices, maybe then you want to call, I don't know, some entity, right, or your friends that may have kind of an off-chain backup kind of shards from this MPC protocol to help you recover. So yeah, I think MPC is a sort of a key management technique that you can use around these wallets to help instantiate them.
But that could still work with, it could still work across different state zones that are leveraging Axelar to ensure the token compatibility across chains.
Yeah.
Okay. And, something that came to mind now is so this is mostly built with CosmWasm.
Yes, the VM itself.
Yeah.
So it's a kind of a hybrid between CosmWasm and some on-chain consensus logic, right? So far, Axelar and a lot of its building blocks have been built kind of by coding the interoperability functions at the consensus layer, right?
Yeah.
So you can use it as a, there's a finality gadget, what we call. There's like a Nexus routing module that we have. There's like a multi-party sign-in module that we have, and so some of these building blocks actually need to be sort of composed with CosmWasm layer to enable interoperability to be extended further, right? And so it's a stack where certain functions from CosmWasm will be extended to the consensus stack to enable for a better efficiency.
So is the Axelar VM essentially like CosmWasm VM but modified
with hooks?
With
hooks to the underlying consensus layer.
Consensus.
Yeah.
Interesting. Okay. Huh. Okay. Sorry, I'm just like this is bringing up a lot of different things. So. This is a little bit what CosmWasm VM is attempting to do, I think, to some extent, right? Like they're trying to abstract away all of the Cosmos module components and then have hooks into consensus directly. I mean, this is off topic a little bit, but and so developers build applications in Rust like as they would on any other CosmWasm VM.
That's right. Yeah, just leveraging the hooks if you need to. But But again, like the role of the Axelar VM is not that you build an application on top of it, right? There's actually two services. One is making connections, and the second one, we haven't talked about it, is what we call as an Interchain Maestro to help you deploy and manage your application across multiple chains.
Okay,
right?
so there's no SDK or anything like that. I mean, it's essentially like you're providing contracts that people can leverage.
We'll provide contracts. There is actually SDKs that have been built. So Cubist is one of our Axelar partners that's building an SDK on top of it to make it even simpler to deploy and build those kind of interchain native applications. So kind of the security itself and the management piece comes from the contracts, but you certainly always have usually an SDK to interact with those contracts on top of it and make it even simpler.
Okay, so tell me about this Maestro, which is kind of like Kubernetes for Web3, I think.
Yeah,
the way you described it.
Yeah, so one of the problems, as I alluded to earlier, has been that developers don't actually spend a lot of time coding the application logic in the interchain. If they want to be deployed across 5 or 10 different chains, they spend 70-80% of their time managing their deployments. Figuring out, how do I put my contracts on this chain? How do I set up governance around it? What does my upgrade path look like? Oh, let me get some gas to actually pay for this stuff. Oh, then I have to have a wallet. Let's back up this kind of a gas. And then you repeat this process 10 times across all the chains that you want to do. But it's the same process, right? And so kind of the idea for the Maestro has been, well, how can we make it easier for the developers to actually deploy their interchain tokens across multiple chains or build their application, right? And so again, it's going to be a set of service contracts that are built on the Axelar network. You can think of them as deployment templates, right? That will help you take bytecode of your contract, set up its configuration, which chains you want to deploy them on. Do you want to have upgrade path for them? Do you want to have admin keys behind them? How do you want governance to look behind them, so you can specify it in the configuration? And then it will just get pushed on all of these different chains. It will be automatically interoperable, so you don't have to think about how do you connect another Axelar gateway. How do these contracts talk to one another? So it will be all under the hood in terms of the orchestration setup. And the analogy that I make is sort of Kubernetes for Web 2. Been doing that, where you write your template, how you want your application to be instantiated across different databases, application servers, storage servers, and things like that. And then Kubernetes helps you manage and deploy that. And so in the same way, kind of the Maestro will help you deploy across different Web3 stacks.
Okay. So again, coming back to an example, let's say you're Aave, right? Like Aave is on a bunch of different EVM chains. Maybe at some point they're on other execution environments. Then they would, instead of having to manage all these deployments, they would use the Axelar Maestro to deploy their contract sets across all these different chains.
That's right.
Does it also do I mean, like, so if they were also doing it on, I say, like a CosmWasm zone, they would also have to have a CosmWasm contract written. Axelar doesn't do the translation into a bytecode for the other execution environments?
Yeah, so we don't, but actually, SDKs like Cubist actually will help you with that, right? So that you can write in a uniform language, right? And from that language, it will kind of serve a
Cubist.
Cubist, yeah.
Cubist, I don't know.
It's kind of a pretty cool SDK that the guys have built in, right? So that's the whole problem has been, how do you create a uniform, application that can talk across multiple different, virtual machine stacks, right? And so. So we don't, we want to do that directly. We'll help you at the networking layer to translate the packets. If you have contracts that need to be deployed, it's sort of a layer on top of it that you can build.
And what chains are supported today for deployments?
So right now it's kind of the virtual machines gone live on the DevNet, which supports all the chains on the DevNet environment, and then from there we'll kind of migrate to the testnet and mainnet from there, and and it'll be available on all chains, right? It doesn't get deployed on one or the other. Effectively, everything that's supported by the Axelar stack as it goes live, it will be available.
But you have launch partners. I mean, I know there was a bunch of launch partners that that were, but this is just for the VM deployments, or
so the launch partners is specifically to help build connections across those ecosystems using the amplifier technologies, right? So like Base, like ZK Sync, a bunch of Stellar, they all need to have connectivity, right? And so kind of using the VM layer, that connectivity can be instantiated simpler.
Okay. And I think there's template contracts also that are part of this VM. Like, what are those contracts for, and like how can developers leverage them to simplify their workflow?
Yeah, so depending on, again, like the different product, right? So for the amplifier, those contracts would be like a universal sort of router contract, right? Okay. So basically, once you build a connection from your chain to the Axelar, again, you want to make sure that the packets can go to other chains already interconnected. Yeah. So you need to enroll with these like router contracts.
Okay. So this is like the router that routes those tokens.
That's right. That's right. Okay. Tokens and messages, right? So that's one example. The second example would be like, let's say you want to deploy your cross-chain token, right? So it's maybe your C20 token. You want to set up, I don't know, admin keys because you want to be able to kind of control, I don't know, supply of this token, right? Or be able to issue more of these tokens. Yeah. So you can go to the Axelar, template contract. You say, these are my admin keys. I want to deploy this contract on chain X, Y, and Z. You invoke a transaction on it. It gets deployed there. The admin keys are set up there. And then, when you need to, let's say, upgrade or execute a command, then you can come in, sign a transaction. The admin keys, I'll sign it. It gets kind of propagated and executed across the different chains.
Okay. With things like upgradability, I can see where, like for instance, there's some Cosmos contracts on, say, Juno, for instance, CosmWasm contracts. They leverage a DAO to do their contract upgrades. Mm-hmm. Because with a CosmWasm contract, you can have like an admin key. They just use a DAO admin key, and then the DAO decides how those contracts get updated. If you're managing multiple deployments across different chains, where would that governance have? Like, how would you could have the governance on one chain, but could you leverage sort of a DAO key to manage this upgrade deployment through Axelar?
Yeah, exactly, right. Like that's one of the goals, is that your management or your functions that authorize upgrades could be executed on like one place. Yeah, right? And then you can propagate that information across other networks, right? So yeah.
Okay. Do you guys have like template contracts also to facilitate, say, community voting on different chains and stuff like that?
Yeah, I mean, we don't have those templates yet, but one of the things we have done was we actually opened up, a grants program, right, a $5 million grants program to help developers build those template contracts, right? Yeah. So we'll work with a lot of teams and to actually think about what are the functions that they want to help managing across the different stacks, and we'll provide some funding, and we'll work with the developers to build this kind of a Kubernetes in a decentralized way across the community.
What kind of things do you hope to see the developer community be like? What do you think is like the low-hanging fruit that developers could be building? Anybody who's watching might want to get some of this grant money.
Yeah, no, I mean, I think governance is actually, is a pretty cool use case, right? There's been a lot of like talks recently about like swap governance, right, and how that has to happen, and what is the kind of upgrade paths there and things like that. I think managing sort of NFTs is the other pretty interesting use case, primarily because there's no kind of NFT standard across different ecosystems. So, everybody has like their own thing. People are trying to standardize it a little bit, but it's still very, very early, right? So figuring out like what is my, Interchain native NFT platform / management needs to look like, I think is a pretty low-hanging fruit as well.
Yeah, that's really cool. I mean, it's a pretty neat stack. Yeah.
Yeah.
How do you guys think of MEV? I mean, we talked about this a little bit last time, but is that you're thinking evolved there?
Yeah, I guess don't remember exactly what was my thinking when we spoke last, but I still believe probably consistently that MEV has to be solved at the edges. Edges meaning like at the application layer, right? So yeah, I mean, I think the reality is that kind of with more and more chains, with more and more components, with more and more asynchronicity across all of these different components, if you want to have some type of order / fairness, it has to be solved as close to the application as possible.
Yeah.
Right.
Yeah.
So, instantiating that at the edges is where I think it has to be done.
Okay. So you don't think that people will start building contract templates to mitigate MEV at the Axelar level, or?
I mean, you can do that, right? Like, so because we have actually like a multi-party sign-in at the protocol layer, you can use like a multi-party, threshold encryption techniques, right? To encrypt blocks of data, decrypt them in a consistent way across them. If people want to do that, like, sure, yeah. I mean, the thing with cross-chain MEV, I think it's right now it's a great research problem, right? It's not something we have seen too much of. I think we're still at the phases where we're building out these interchain applications that actually have, good throughput, good user experiences, right? With significant volume, where MEV is actually a problem. So we should continue doing research, I think, around those topics, right? I think we should continue building solutions over them. Do we need them, tomorrow or next month? Probably not yet.
Yeah, I think that's fair. I mean, I also agree that MEV probably needs to be solved closer to the edges, and also applications, stand to benefit from solving that problem close to the edges where like value can flow back to users, etc.
Right.
Yeah. I wonder, is there a future where Axelar is also providing some form of security guarantees to chains? Like, I mean, this whole interchain security narrative, or mesh security.
Yeah.
Since you guys are going to be connected to all these chains and all these rollups, etc. Like, does that make sense, or is that something that you see as a long-term vision?
I mean, I think security is going to be more and more mixed, right, across different stacks. So, in Ethereum ecosystem, you have a lot of kind of eigenlayer types of approaches, right, that use the Ethereum token for security and instantiate in certain applications. Within Cosmos, we have interchain, like mesh security, right? I think those are kind of a general trends that we're seeing more and more of, where one chain can borrow security, can lend security across from another. Things get a little bit complex there, frankly, for security and other things. So you have to be kind of a pretty delicate. So maybe at some point we have kind of conversations with Osmosis, right, and a bunch of other folks to kind of both borrow and lend security across these chains that provide value to each other in some sense. I think we're going to see more of it. I think next year we're going to see the build outs of those technologies, and we'll kind of see them instantiated after that.
Maybe, I mean, a related topic here, but what's your how do you reason about all of the different types of execution environments that developers have access to today, right? So I mean, if you want to build something on a blockchain today, you want to build a dApp, you can go the simplest route, which is like you can build a contract on any number of chains, and you can probably use Axelar to orchestrate all those contracts. And I mean, actually, it could also maybe serve to scale smart contracts to some extent, because you're sort of spreading that the block space across different chains. And then there's like, of course, the Celestia vision, which is decoupling consensus from the execution and settlement layers. And then you have like the Osmosis vision, which is like, we're going to control every layer of the stack, because the application necessitates every layer of the stack being controlled. And I sort of see that as the Amazons and the Googles of the world, right? They're building their own data centers. They're not going to be building on someone else's cloud. How do you reason about which types of these configurations are better suited? Like, how should developers think about what to use if they're building an application? And as an orchestration layer, are you guys also thinking about helping developers choose the right being sort of a steward there, and helping developers choose the right type of infrastructure, I guess?
No, it's a great question. So I think one thing, I think kind of for a developer as they're starting to build, right, you have to think about what are you building, what is your go-to-market, right? And like, what is your user acquisition strategy, and like, what properties your application needs to have. So as an example, let's say you build in some kind of a sophisticated sort of financial primitive that has very interesting like liquidity properties. Okay, do you want to build your own app chain for that? And I claim probably not. If you experimented at the application layer logic and you don't know whether or not your application even has a product market fit, probably just want to take some contracts, write them over a week, deploy like on one chain or a couple of chains, and see if anybody would even interact with those things, right? You have to think about your interchain strategy from day one, like how you want to scale from that. But you want to kind of go to market as quickly as possible, right? And like, you need to use the tools that will allow you to do that. If you are building something where there is a product market fit, so decentralized exchanges, we've seen them, right? Like, we know more liquidity, better UXs will lead to ultimately more scalability for these decentralized exchanges. Then you have to say, okay, what is my long-term future to provide then these kind of a extra level of services that my competitors would not be able to provide. And that maybe means building your own stack and controlling it from the ground up, right? Where you can control the full execution, you can have reliable kind of transaction fees and so on and so forth. So yeah, I would say kind of for developer, the simple template you can follow is say, okay, this is my application. Do I have a product market fit? If not, find the easiest, shortest path to go to market and like figure out if anybody is going to use that.
Yeah.
If you're trying to kind of improve and innovate on the products that have usage, then you want to think maybe about controlling some parts of the stack or scaling to as many chains as possible, kind of from the get-go, because those will be your differentiators, right? So you have to have those differentiators.
Yeah, but I mean, in the long term, do you see Axelar having a significant role in just being sort of an entry point for, like, say you're a new blockchain developer, you want to deploy your application, to as many ecosystems as possible. You're going to come up with that, you're going to start interacting with Axelar, and then, Axelar may also provide some tools that helps deploy those applications to the right type of infrastructure. So
right.
Like if it's like a rinky-dink little
right.
dApp, you might just want to deploy as a smart contract on Ethereum and all the EVM chains.
Right.
But if it's something more complex, in the same way that you can use DigitalOcean today to like launch a WordPress site, just like in one click, you can also use it to launch like a Kubernetes cluster, and like the interface helps you figure out what you need, and there's applications already there.
Yeah, right. Like I think that's reality, right? Like you're gonna have to go, and you're gonna have to, you're gonna need a place where you can manage your application across multiple chains, right? And potentially, like through the sort of Kubernetes stack and like the tools and the templates that we're building, we'll be able to do that for the users.
Cool. So yeah, before we wrap this up, what's next on the roadmap?
That is next on the roadmap is a kind of building this sort of ecosystem, right? Working with a lot of developers to help think about what are the use cases, what are the template contracts they actually need, how do we instantiate them, thinking about protocols across the full stack. So yeah,
cool. Well, thanks so much for doing
awesome.
This. It was really
Thanks
fun.
for having me.
Really interesting, and I look forward to being here again next year when you do this again.
Awesome. Thanks for having me on the show.
Thanks.